Hello, everyone. I'm Chad Anderson, founder and managing partner at Space Capital. In 2020, we wrote the GPS Playbook. It's essentially our seminal thesis paper, which explores how space-based technologies have become and will continue to be the main platform for innovation on a global scale. Now, Trimble featured prominently in that report. Early infrastructure investments in GPS satellites were leveraged by tech pioneers like Trimble, who not only made the signal more useful and accessible for the military, but also unlocked a new commercial market. In 1984, Trimble brought GPS technology to market with the release of the first commercial GPS products for accurate timing, offshore oil drilling, and enhanced maritime navigation. They have been at the very center of things since the dawn of the commercial space era. And that's why I'm very excited to be speaking with Ron Bisio, Senior Vice President of Geospatial at Trimble. Ron, thanks for joining us today.
Thanks for having me.
So you bring a very interesting background to the company. You have degrees in cartography, regional planning, and business. And you've also been with the company for much longer than most, I'd imagine. And you've worked with, across several functional areas in the business. Can you tell us a bit more about your background and how you've seen positioning and geospatial intelligence evolve over your time at Trimble?
Yeah, thanks. Yeah, so as you mentioned, rather unique having a degree in cartography. I was there sort of at the beginning when we were making the transition from manual cartography, Mylar-based map creation to actual early days of GIS. And I was very fortunate after school to spend a few years working at Esri, leader in GIS software. But given my love of sailing and navigation and positioning technology, the first time I had an opportunity to, in 1996, I moved over and started at Trimble as a product manager in the organization. Early days of Trimble, still with Charlie Trimble at the helm, and really interesting and exciting time to be there. And a little bit, you asked a question about the evolution. And so when I first joined Trimble, I was in the mapping and GIS group, really, where GPS technology was being used for mapping utility infrastructure. And, at that time, it was very much a one-way workflow. Somebody would go out, they'd use a GPS receiver, they'd capture the positions, they'd capture some rough attributes, and that would end up in a GIS. And then, what we've seen since then is the evolution to what we call an ecosystem, where you've got the GPS, drones, scanners, lots of technology for capturing data, feeding it into a system of record. But what's really exciting is now that data is now going back out into the field. And so whether it's being for updating the spatial data or for relocating or for maintaining physical infrastructure, that's a really exciting trend that has really changed since the one-way workflow when I first joined Trimble back in 1996.
And we are now seeing a wave of transformative new applications being built on GPS. The last decade in particular, we've seen an exponential growth of GPS applications. In your view, what are the most interesting new applications that are being enabled by high precision technology, next generation positioning?
Yeah, so I think there's a few things. First off, what made it so that we could have these new applications? I think one of the things that's been really interesting is just how the technology has evolved from an availability standpoint, a cost standpoint. If you think of the early days of GPS receivers, very expensive, very complex to use, and limited availability. There are stories about people in oil and gas having to work in the middle of the night when they had enough satellites. Now, with obviously the US GPS, GLONASS, Galileo, new constellations coming online, there's considerably more availability, which has now opened it up to these new applications that are happening there. One of the most interesting, the new applications, of course, I love is agriculture. Precision agriculture, started really with GPS simply guiding a tractor, but when I talk about that ecosystem concept, now you've moved into a situation where you're capturing data about crop health, about field health using drones, satellite imagery, microsatellites, plus GPS, feeding that in. You've got intelligent application of fertilizer or other materials for the fields, and then finally being able to assess the health of the crops throughout their growing cycle. And where that's going to end up is, of course, with autonomy. So it's really been interesting to watch from much more ubiquitous GPS right through to all these additional other satellites, drones coming in, providing more data in, making more intelligent solutions, and then finally leading that right into autonomy.
And we've heard for a long time that, as people talk about what are the next applications, what are the biggest areas, we've heard agriculture pop up several times. I'm curious, we've got several companies in our portfolio that are focused on precision agriculture. And we definitely see the opportunity there, especially with the new satellites that are going up. I think for some people who have been in the industry and have been watching this space, it's taken a little bit longer than I think most people would have expected. I mean, tractors have started using GPS to navigate and guide their tractors quite some time ago. So, in your view, what's been the barriers to adoption for agriculture using this type of data fusion?
Yeah, it's interesting. Whether it's agriculture or its use of GPS for GIS data collection, almost anything in our industry, there's two things that need to come down and two things that need to go up. And I think about it, first off, everything with the entire ecosystem, the cost needs to come down. Every time the cost comes down on something, whether it be mobile mapping or precision agriculture, you get you obviously broaden the pyramid, you get a whole new group of new users who can come in. So cost needs to come down. Complexity is really the thing. When an individual, whether it be a farmer, a grower, or a GIS manager, needs to stitch all the pieces together, the complexity gets put into the too hard bucket. So I think as these ecosystems come together and the sources of data are more easily used, which is where the cloud comes in nicely, I think that's going to bring that complexity down. Availability, as I mentioned before, needs to go up. Availability of positioning, availability of wireless, availability of cloud offerings, all of those things bring up the availability. And then finally, the last thing that needs to come up again is the movement from technology positioning to answers. Whether it's a farmer or somebody running a railroad, they don't care about as much about the satellite or the scanning rate or the GPS positioning technology. Are my crops healthier than they were before? Where do I need to apply my material? Is my train going to safely make it through this tunnel? Those are the kind of answers people are looking from geospatial solutions. And as we as an industry get better about delivering answers, that's when we bring more people on board. Cost and complexity have to come down. Availability and answers have to go up.
And Trimble's played a large role in that. Can you point specifically to, a couple of things that Trimble has done to make geospatial data collection and distribution processes more scalable than where they were a decade ago?
Yeah, so I think, well, first off, so we've had a lot of help from governments around the world by putting up more satellites. When we had GPS, you had obviously 24 satellites up there, and there were times when you'd be blocked behind buildings and things like that. With GLONASS, with Galileo, with Beidou, all these systems, it just puts up many more satellites. So it gets much more, there's very few places where, you're struggling to see the satellites. We've spent a lot of time working on a few areas. One is wireless. By bringing up wireless and more correction services, we now make it so you can get better positions in more places. So correction services have become more ubiquitous. Used to be that you'd have to go out and you might spend your day capturing data in the field. You'd have to go back to the hotel at night, you'd download a file, you'd post-process the data, you might then email it off to your colleagues at 11 o'clock at night. And so by the time that field data that was collected during the day, they might not get it till the next day. Now with the availability of satellites, with the correction services, with strong wireless, and with our improvements in our workflows, you're actually capturing data in the field that in real time is ending up back in the office. completely corrected, ready for use. And that's especially important with things like fighting forest fires, obviously in defense and intelligence, that getting real-time data is much, much more important. So I think some things, we've gotten some help from the government. We've spent a lot of time making sure that our GPS receivers work in many, many places. We've got these great correction services, and we spent a lot of time working on the workflows. More ubiquitous cloud offerings is going to make it even better.
Got it. And oftentimes early movers in a market can get lost in the current as momentum starts to pick up. How has Trimble managed to maintain its leadership position in GPS and geospatial intelligence over all these years?
Yeah, it's an interesting one because you're right. It is really, we were first movers, and it's very easy at this point to even take a board from a Trimble or one of our competitors, put it inside a GPS receiver, and off you go. You're building a survey system. What we do is we have spent a lot of time with bringing employees on board and retaining employees who have a considerable amount of domain expertise. So just outside this office here is my team, and a lot of them are registered surveyors or they're geospatial professionals. They come out of the industry. They bring an amazing amount of domain expertise. They have a high degree of customer focus. We spend a lot of time out visiting our customers, out working with our customers. We were customers in many cases. And what that does is that leads right back into the innovation that keeps us 2-3 steps ahead of the competition, and even just, whether it be a low-cost competition or high-end competition. So it's that strong focus on domain, spending time with customers, and then the innovation. And if you think about a survey company, their receiver is probably one of their second most expensive assets after their trucks. So these guys that work out here in my team, they used to be surveyors, and when we get ready to launch a survey receiver, I say, would you spend your money on this? Would you buy this? Would you bring this into your company? And we won't launch it until they answer that question. That absolutely, this is going to improve what I was doing before.
That's great. And have you seen a difference in the types of skill sets that you're hiring for over the years and over the last few years in particular?
Yes. No, we have absolutely seen a difference in the skill sets, and the industry as a whole has a lot more to do to bring in the people we need. So, for example, we have a lot of people that come out of survey or geospatial. What we need more and more of is people who understand database design, people who understand cloud technology. These are the kind of skill sets that we're going to need, because the surveyors and geospatial professionals of the future are very much data managers. They're very much making sure that the data can be visualized by the owners and the people that need to see it downstream. So it's not just the old days of handing off a USB and moving on, or printing out your maps and then moving on. It's being the custodian of that data and providing it for the downstream users.
Interesting. And where would you rate talent and the people that you're looking to hire in terms of growth of the category? Is that one of the top challenges that you see to growth in this category, or is it something else?
Absolutely. No, it's actually a really big issue. It's probably one of the biggest issues we face in the industry. I've been to many customers who've said, look, I could buy more of your gear if we had more surveyors. And it comes down to we are spending a lot of time and now resources on helping educational institutions improve their surveying schools. There was a period, unfortunately, where a lot of community colleges shut down their surveying programs. And this is not just a US problem. This is in Germany. I've talked to customers in the UK, talked to customers in Australia. The ability to find surveyors and geospatial professionals is a real issue. So I'm actually now taking my messaging down to high schools and saying, look, if you've got people who are strong in math, but don't want to spend their time in a cubicle, they want to be outside, this is a great career path for them. And what we're working with is we're helping the schools to improve their curriculum as well, so that they actually bring in these skills that we're going to need in the future: database design, cloud technology, understanding of AR, augmented reality. These are the kind of things that are also, quite frankly, really appealing to the next generation of workers in the field.
One of the key takeaways from the GPS playbook was exploring new applications available from the convergence of GPS and computer vision. And actually, the last time that you and I spoke, we discussed the GPS playbook. We already mentioned about how it's a platform for innovation on a global scale, but specifically the development of technology layers on top of the space-based infrastructure and the distribution of that data for mass adoption, which unlocks thousands of unique applications. You and I were discussing that framework and got to talking about the convergence of GPS positioning and geospatial intelligence and mapping. And I'm curious, how you're thinking about AR solutions. I mean, smartphones have obviously been the most widely used GPS-enabled device thus far. Do you believe that AR wearables are next? Is this something that you see in the enterprise type applications that you're developing?
Yeah, so we're certainly seeing the growth of wearables, AR, augmented reality wearables in buildings, in the building space. Obviously, with Trimble's doing a lot of work with Microsoft around the HoloLens on building construction. If you look at the traditional survey, geospatial, in the field work, what I think it really does is augmented reality brings situational awareness. If you're working in construction or you're working on utilities, what you're really interested in is what else is around. What other utilities are buried here? What is the situation around? Whether you're putting a blade into the ground or you're simply mapping other utilities, you want to know what's around. So I think the exciting future for field is to integrate AR into the traditional workflow, so that when I'm surveying or I'm about to drop that blade into the ground, or that bucket into the ground, I can automatically see, without having to do a lot of other things, the situation around me, the data around me. And that's the end state we all want to get to, where before you put the bucket into the ground or before you're doing your survey work, you can see all those things. Now, what that's going to require is we're going to need to map the underground infrastructure. So we're going to need to know where the broadband is. We're going to need to know where the gas lines are. And so that's actually a huge market opportunity for surveyors and for geospatial professionals to go out and map all of this underground utilities so that we can build that situational awareness that takes, call before dig and 911, things like that, to the next level.
Mm-hmm.
I think
is that something that Trimble's working on? Sorry,
absolutely, yes. Yeah, no, absolutely. We're very focused. In some places, we are very focused on the wearables and the HoloLens type solutions. In others, especially in my business, geospatial area, we're really focused on making augmented reality part of the standard solution. So it's part of the daily workflow of the user. Eventually it'll just kind of blend into the background. You'll just turn your system on. It'll go out on the cloud, find all the data around you, and then build up that situational awareness of what's around you.
So in terms of underground mapping what's underground, is this something that you're looking to work with partners on?
Yeah, we actually do. We work with partners in multiple areas. Ground penetrating radars is technology that's interesting. A lot of other, there's a lot of even startups that are starting to work on really exciting technology for underground mapping. This is everybody recognizes this is going to be a really big opportunity for, quite frankly, for safety, for making crews safer, and for improving utilization of the underground area.
Makes perfect sense. The space economy is clearly at an inflection point. And I'm curious, as you look into the future, given all that you've seen and all of your experience, what are you most excited about?
It comes down to really one word for me. It's fusion. It's whether it be sensor fusion. So one of the things that's allowed us to take our GPS systems to the next level is combining multiple technologies together. We're now bringing, multi-constellation GNSS receivers with IMU. We're looking at close-range photogrammetry, visual odometry. All of these technologies are coming together to make it so that you can work in any place. Surveyors can always continue to get positions wherever they're working, under canopy, up against buildings, things like that. So that fusion at the receiver level is really exciting. And then the other place where that fusion is coming together is the ecosystem I talked about before for capture. Used to be a survey company might have a GPS receiver and an optical instrument. Now they very likely have a drone. They've got a scanner. They've got potentially mobile mapping systems for doing linear corridors. They may have a relationship with somebody who's got a helicopter-based LiDAR system. So there's so much more data coming in that all needs to be brought together and then delivered downstream to the customers to, again, get to those final answers that the customers want. So again, we're removing the complexity by fusing the technology together on the GNSS receivers. In the ecosystem, we're making so all that data comes together in applications like Trimble Business Center, where you can take your traditional survey data, plus scan data, plus UAS data, plus LiDAR data, mobile mapping data, bringing it all together in one place and then delivering answers to your customers.
Ron, this has been great. I could talk to you for a lot longer, but I want to be respectful of your time. Really appreciate you taking the time to talk to us today.
I really enjoyed it. Thank you very much.